Hello everybody. We're going to talk about ratios, proportions, and similar polygons in this lesson. So we're going to work through the unit step by step, and you're going to be able to do all of these tasks by the time that we're done. First, we're going to talk about what is a ratio. A ratio is a comparison of two numeric terms, and there are two ways to write a ratio. We can do it with a colon or as a fraction. Our first question asks us to write the ratio of 7 cars to 10 trucks. And again, we said we can write it two ways, as a colon or as a fraction. So we could write it 7 to 10, 7 cars to 10 trucks, or we could write it 7 over 10, write it as a fraction. And of course, if this fraction could be reduced, we would reduce it. So two ways to write a ratio. Let's do some ratios looking at the table beneath of quarterback statistics. What if I asked you to write the ratio of touchdown passes of Tom Brady compared to Ben Roethlisberger? We look at our chart, we see those touchdown passes for Tom Brady is 32. The touchdown passes for Ben Roethlisberger, 28. So that ratio is 38 to 28, or as a fraction, which is almost always how I will write it, 32 over 28. Now you should notice something about this fraction. That's right, it divides. So let's go ahead and divide. It doesn't matter how you divide it. Maybe you just divide by 2 and get 16 over 14. And notice that reduces by 2 again, 8 to 7. So the ratio of touchdown passes for Tom Brady and Ben Roethlisberger is 8 to 7. Next, we're asked to find the ratio of touchdown passes between Alex Smith and Russell Wilson. We look at the chart and we see that Alex Smith threw 26 touchdown passes. Russell Wilson threw 34 touchdown passes. So our ratio is 26 to 34. Again, this reduces. We can reduce both by 2, and we get 13 to 17 is the ratio of touchdown passes between Alex Smith and Russell Wilson. Let's do the next question, which is the ratio of interceptions between Philip Rivers and Alex Smith. Philip Rivers threw 10 interceptions. Alex Smith only threw 5 interceptions. I want you to be careful here. When we reduce this, you notice it reduces. You notice they both reduce by 5. We're going to leave this as 2 to 1. We're not going to just say 2, because remember, a ratio is a comparison of two terms, and I need to have both terms, the 2 and the 1. So this is the very rare case where when we have 2 over 1, we're just going to leave it 2 over 1. Philip Rivers threw 2 interceptions for every 1 interception that Alex Smith threw. Now that we've talked about ratios and you've done some for the NBA standings, let's talk about a proportion. A proportion is simply a comparison of two ratios. So we have some proportions beneath, and we want to know, how do we know if they're true? Well, let me look at the first one to help you work through it. We want to know, does 3/5 equal 12 over 20? And it doesn't matter what we're talking about here for the situation. Maybe we're talking about the dimensions of a picture. A picture that's 3 by 5, would it look the same as a picture that's 12 by 20? Would it have the same proportions? Maybe we're talking about cars and trucks, or touchdowns and interceptions. It doesn't matter what the problem is. We want to know, is this true? And the way we do that is we cross multiply. And these actually have or names to them. When we multiply this way, the 3 times the 20, we know 3 times 20 is 60. And this is called the extreme. I misspelled there for a second. And when we multiply this way, 5 times 12, that is also 20 or 60, and that is the mean. So when we cross multiply, and the mean equals the extreme, then we know that our proportion is correct. Or we could say it's true. It's true that 3/5 equals 12 over 20. Here's our next proportion. We want to know, does 2/7 equal 6/21? Is it the same thing? 2 over 7, 6 over 21. We cross multiply. 2 times 21 is 42. 7 times 6 is 42. This is the extreme. This is the mean. They're the same. 42 equals 42. Therefore, this proportion is true. It's as easy as that. You're doing it faster than I can explain it, I'm sure. Let's do the last one. I'll fit it in here. Is 5/6 equal to 15 over 24? We cross multiply. 5 times 24 and 6 times 15. 5 times 24 is 120. 6 times 15 is 90. Those are not equal, so this proportion is false. They are not the same. So for instance, if you had a picture that was 5 by 6 and you enlarged it and made it 15 by 24, things would get out of proportion. It would get stretched, or it would get either really tall or really wide. So we cross multiply. If they're not the same, our extreme and our mean, then the proportion is false. Now you try to find if the proportions on the next page are true or false. Okay, so we've talked about ratios. We've been able to figure out if a proportion is true or false. What if they give us a proportion and we're missing a letter or a number? What if we want to find the number that makes this proportion true? How do we do that? Well, the key is the phrase cross multiply and divide. Cross multiply and divide. That's what you're going to be saying over and over in your head as you do these problems. Cross multiply and divide. Now when you look, you're going to have to say, well, which numbers do I cross multiply? And the thing to remember is when we cross multiply, it's diagonal. Remember how we did it with the proportions true or false. We either did the mean or the extreme. We did it diagonally. Now, which are the only two numbers here that multiply diagonally? You're right, the 5 and the 18. So we multiply 5 and 18, and then we divide that number by 2, by the only number that we haven't used yet. So in this, we would cross multiply 5 and 18, and that gives us 90. And then we divide that answer by the only number that's left, the 2. 90 divided by 2, x equals 45. Cross multiply and divide, and you only can cross multiply by the whatever two numbers there are, diagonally. Let's do the other examples. 3 over 8 equals x over 20. How do we solve it? Cross multiply and divide. What two numbers here are diagonal, which means I can actually multiply them. I look and I see that the only two numbers I can cross multiply are the 3 and the 20. 3 times 20 is 60, and then we divide that by 8. And what do I get when I divide 60 by 8? It's actually going to give you a decimal, and that's okay. You are going to get decimals on these. 7.5. So x equals 7.5. Cross, multiply, and divide by whatever two numbers are diagonal from each other. Those are the two that you multiply, divide by whatever's left over. Here we have the x on the left side. X over 6 equals 4 over 24. How do we solve it? Cross, multiply, and divide. What are the only two numbers diagonally from each other? 6 and 4. Multiply those to get 24. Divide by the only number that's left, the 24. What's 24 divided by 24? Oh, x just equals 1. 1/6 equals 4 over 24. Last one, 7 over x equals 24.5 over 35. We want to solve for x. We have to cross multiply and divide. Cross multiply means the only two numbers I can multiply in this problem are 7 and 35. I multiply those, I get 245. I divide that by the only number that's left, 24.5, and I find that x equals 10. And now you know how to solve a proportion for a missing term. Cross, multiply, and divide. So now we're going to apply these concepts of ratios and proportions to polygons or shapes. We want to know if we take a shape and we make it bigger or smaller, how to keep it in proportion. Like I said, if you had a picture, if you drag a picture onto a Word document on your computer and you want to make it bigger or smaller, but you want to keep it in the same proportion so it doesn't get stretched out or squeezed in. Now, how do we do that? Well, we have here the polygons are similar, and we show the symbol with a little wave, if and only if the corresponding angles are congruent. The angles have to be the same in both polygons. If I have a 60-degree angle over here, it has to be 60 degrees over here. 55 degrees over here, 55 degrees over here. And what about the sides? The sides all have to be proportional. No matter which side you take, the proportion has to be the same. If those two things are true, if all the angles are congruent or equal, and all the sides are of the same proportion, then you have similar polygons. Let's look at a couple. I have two triangles, and I didn't draw them. I figured you could draw them yourself, and it doesn't matter what they look like. I'm going to say ABC and DEF, and I gave you some sides. AB is 4, BC is 10, and DE is 9. Now, if I tell you that these two polygons are similar, then you know that the angles are the same, because I've told you already that they're similar. So maybe this is 40 degrees. That means this has to be 40 degrees. But the angles don't matter in these problems. All we're really doing is solving for a side length, and over here I want EF. So how are we going to do that? We're going to set up a proportion. And you actually have some choices with how you set it up. I'm going to keep all of one polygon on one side of the equal sign. So I'll say AB 4, BC 10. Now I have to be careful. What's the same side as AB on this triangle? Side DE. So since 4 is on top, 9 has to be on top over here. And EF is what I'm looking for. And as you know, we're going to cross multiply and divide. Cross multiply 10 and 9 is 90. Divide that 90 by the only number left, the 4, and x equals 22.5. And you have found the missing side length of similar polygons. Our next polygon has 4 sides, ABCD QRST. And I give you the lengths of several sides, but we want to find some missing sides. So let's draw it. And we don't necessarily care what it looks like, but sometimes a drawing will help you. You don't even need to draw it if you can keep all of this straight in your head, but I will draw it just to make sure I do that. So they have to be similar, so they're going to look the same. And QR is 12. So we want to find the rest of the sides. So we're going to actually have to do 3 problems because we're missing 3 sides. So I have AB over here, which is 4. And I have QR over here, which is 12. And I might as well just go alphabetically. BC is 6. And that means I can find whatever RS is going to be. Cross, multiply, and divide. 6 times 12, 72. Divide that. I'm going to write the answer down here. Divide it by 4. 18. RS is 18. Let's find another side. I'm going to stick with AB and QR. And now I'm going to find ST. So ST is the same, is similar to CD, which was 9. Cross multiply, 9 times 12, divide by 4. So 9 times 12 is 108. If I divide that by 4, I see that ST equals 27. Okay, good. Only one more side to go, and that's QT. So I'll start again with AB is 4, QR is 12, AD is 3, so what is QT? Cross, multiply, and divide. 3 times 12, 36. Divide that by 4. QT equals 9. And now you've found the lengths of all the other sides of your similar triangle. And you can see that what I did is I tripled it from here to here. Everything is times 3. All right, this last one's a fun one because it's something that you might actually have to do at some point. You have a picture that is 4 by 6. So it's 4 by 6. It's wider than it is tall. And you want to put it on a piece of paper that's 8.5 by 11. But you know that paper is taller than it is wide. So right away you realize we have a problem. If I have a picture that's fat and a paper that's tall, something's going to get messed up. And we want to know how big can I make this picture proportionally to fit on the paper. So the picture is 4 to 6, the ratio. Now the ratio of the paper, let's think. Are we going to make this picture 11 inches tall? Are we going to stretch it to be 11 inches tall? Or are we going to widen it to be 8.5 inches wide? Well, we're going to try it both ways. Let's say you want to make it 11 inches tall. Well, since it's 4 inches tall in the picture, we're going to make it 11 inches tall. We would cross multiply 66, and we would divide by you get 16.5. My paper isn't that wide. So this doesn't work. So let's try it the other way and make it 8.5 inches wide. We still have 4 by 6 for the picture, but this time we're going to make it 8.5 inches wide. Now we cross multiply and divide. 4 times 8.5. That is, I believe, 34. I'm actually going to have to write that out just to make sure. Yep. And then we're going to divide 34 by 6. And that is 5.66 repeating. So in order to take our picture and put it onto a piece of paper as large as we can be without losing proportion, that picture will be 8.5 wide, so it will fill up the entire page widthwise, but it will only be 5.6 repeating high. So we'll have some extra space on the top and the bottom. On page 10, the problems get a little bit more difficult. They give us two shapes, two polygons, and they tell us that they are similar. They give us ACDF with dimensions of 12, 9, and X. And they give me upside down, of course, to make it even more difficult, VWYZ with dimensions of 6, 10, and 3y minus 1. Now we need to solve for X and Y. Well, let's go back to the directions because that will help. ACDF is similar to VWYZ. And remember, these letters are important. So if I look here at side AF, which is the first and the last letter, it tells me that that is similar to VZ, the first and the last letter. And I know that that is 3y minus 1, so we're going to have to find that one. Just like CD is the middle letters, 9. They're similar to WY, the middle letters, 6. So let's set that up. AF, outside letters, 12. Over CD, inside letters, 9. Equals VZ, outside letters, 3y minus 1. WY, 6. Now, how do we solve a proportion? We cross multiply and divide. But we have a variable here, so we're going to kind of do this just slightly different. Bear with me. We know that the extreme, 12 times 6, 72, has to equal the mean, 9 times 3y minus 1. What does that look like? Oof. 9 times 3y minus 1 means, oh, we have to distribute. Remember when we had parentheses outside? Anytime you have parentheses outside, it means distribute. Multiply by everything inside. So 9 times 3y is 27y. 9 times negative 1 is negative 9. Now we can solve for y. I'm going to add 9 to both sides. 81 equals 27y. I'm going to divide both sides by 27, and I'm going to see that y equals 3. If y equals 3, that means this side must equal 8. All right. So we solved for y. Now we can solve for x. And of course, it doesn't matter the order we do these in. Again, I'll use AF 12. This time to find x, that's DF x. So AF, first and last, is the same as VZ, first and last. And we just said VZ is 8. DF, the last two, YZ, the last two, is 10. How do we solve? This one's a lot easier. 12 times 10, 120, equals 8 times x, or 8x. Divide by 8, and x is 15. So that's how we can use proportions to find missing sides, even if there's letters involved. The first thing I want you to notice about this problem is that they have spun your triangles trying to trick you. And not only have they've done that in a way that if you're not being careful is going to mess up your entire problem. Now, how do you avoid being confused? Well, when you label your triangle on the left, and it doesn't matter what you name it, but I'm going to name it JML. Because I'm going to go 1 arc, 2 arcs, no arcs. Then on the right, I have to label it the same way. If I did 1 arc, 2 arcs, no arcs, over here I have to do 1 arc, Q, 2 arcs, T, no arcs, S. And as long as you keep that labeling the same, 1 arc, 2 arc, no arc, 1 arc, 2 arc, no arc. Or you could have done no arcs, 2 arc, 1 arc, no arcs, 2 arc, 1 arc. As long as you're the same for both polygons, both triangles, or whatever the shape is, you're going to be okay with these problems. So now they have X and Y on the same triangle, so we're going to have to pick which one to solve first. We must always do X first. Last problem I did Y first, but it doesn't matter. Let's do X first. Well, we're going to do JM 4 over ML 6x minus 3 equals, now JM, what's the same side? JM is the first 2 letters, QT, QT is 2. ML, last 2 letters, TS, TS is 3. And that's how we initially set it up. It's very important that you have all of these in the same spots. Now we cross multiply. We know that our extreme 12 has to equal our mean 2 times 6x minus 3. We know we have to distribute 12 equals 12x minus 6. To solve, we add 6 to both sides. 18 equals 12x. I'm sorry I'm running out of room, but we find that x is 1.5. If I put 1.5 back into here, 1.5 times 6 is 9 minus 3. This side has a length of 6. I'll use JM, the first 2 letters. That means I'll use QT, the first 2 letters, 2. I'll use JL, the outside letters, 3y minus 2. I got to use QS, the outside letters, that is 5. Cross multiply. My extreme is 20. My mean, and I'm going to distribute in my head. I'm not going to write it again. 2 times 3y minus 2 is 6y minus 4. I add 4 to both sides. 24 equals 6y. I divide by 6, and y equals 4. If I put a 4 in there, that tells me this side equals 10. And now we can see what we did with our triangles. We went from 4, 6, 10 to 2, 3, 5. We shrunk it in half. Of course, the drawings aren't going to show that. The drawings are not proportional or not to scale. So you can't trust the drawings to say that this triangle isn't half the size. You have to trust your math. But this is how we find missing sides, especially when they have a variable of x or y. Cross multiply your mean, cross multiply your extreme, and solve for the variable. All right, so think about this. If we have 2 similar polygons, that means every pair of sides, the right side from one and the right side from the other, the left side from one and the other, all the sides have the same proportion. So like if one side was 1, if I just drew let me just draw a rectangle. Actually, let me draw something that's not a rectangle. So what I'm talking about is if one side is a 1 and one side in this weird shape is a 3, and this side's a 2 and this side's a 6, you see where I'm going. If this side's a 4, this side's what? A 12. If this side's a 5, this side's a what? A 15. Okay, so if I multiply by 3 each time for side length, what do you think that means about the perimeter? Let's see. Perimeter here, 12. Perimeter here is, that's right, 36 times by 3. So if the sides have the same proportion, then the perimeter has the same proportion. And we have one example like that that we're going to do together. I don't give you a lot of information about our shapes. Who knows what they look like? A, B, C, D. I say AB is 4. And I say we have W, X, Y, Z. And WX is 12. I tell you the perimeter of the small shape is 30. We want to know the perimeter of the larger shape. We set up a proportion. 4, the length of a side, 30, the perimeter. 12, the length of the corresponding side, and the perimeter that we want to find. We cross multiply. We divide, and we find that the perimeter of this shape is 90 because it's 3 times as big. So 12 times 30 was 360. We divided that by 4. We found the perimeter of this second shape to be 90. And now you know how to find if a proportion is true or false. You know how to find the missing number in a proportion. You know how to find missing side lengths. You know how to find side lengths if they have X's and Y's. And now you know how to find perimeters if I just give you one set of sides.